Lesson 42. Recording an earthquake. An earthquake comes like a thief. In the night, without warning, it was necessary, therefore, to invent instruments that neither slumbered nor slept. Some devices were quite simple. One, for instance, consisted of rods of various lengths and thicknesses, which would stand up on end like napkins when a shock came. It shook the rigid table upon which this stood. If it were gentle, only the more unstable rods fell. If it were severe, they all fell. Thus, the rods, by falling and by the direction in which they fell, recorded for the slumbering scientist the strength of a shock that was too weak to waken him, and the direction from which it came. But instruments far more delicate than that were needed if any really serious advance was to be made. The ideal to be aimed at was to devise an instrument that could record with a pen on paper the movements of the ground or of the table as the quick passerby. While I write, my pen moves, but the paper keeps still. With practice, no doubt, I could in time learn to write by holding the pen still while the paper moved. That sounds a silly suggestion, but that was precisely the idea adopted in some of the early instruments. Seismometers for recording earthquake waves. But when table, pen holder, and paper are all moving, how is it possible to write legibly? The key to a solution of that problem lay in an everyday observation. Why does a person standing in a bus or train tend to fall when a sudden start is made? Or was to be made? It is made. It is because his feet move on, but his head stays still. A simple experiment will help us a little further. Tie a heavy weight at the end of a long piece of string with the hand held high in the air. Hold the string so that the weight nearly touches the ground. Now move the hand to and fro and around, but not up and down. It will be found that the weight moves but slightly or not at all. Imagine a pen attached to the weight in such a way that its point rests upon a piece of paper on the floor. Imagine an earthquake shock shaking the floor, the paper, you and your hand. In the midst of all this movement, the weight and the pen would be still, but as the paper moved from side to side, under the pen point, its movement would be recorded in ink upon its surface. It was upon this principle that the first instruments were made, but the paper was wrapped around a drum, which rotated slowly. As long as all is still, the pen drew a straight line, but while the drum was being shaken, the line that the pen was drawing regularly from side to side. The apparatus thus described, however, records only the horizontal component of the wave movement, which is in fact much more complicated if we could actually see the path described by a particle such as a sand grain in the rock. It would be more like that of a blue bottle buzzing around the room. It would be up and down, to and fro, and from side to side. Instruments have been devised and can be so placed that all three elements can be recorded in different graphs. When the instrument is situated at more than 700 miles from the earthquake century, the graphic record shows three waves arriving one after the other at short intervals. The first records the arrival of longitudinal vibrations. The second marks the arrival of transverse vibrations, which travel more slowly and arrive several minutes after the first. These two have traveled through the earth. It was from the study of this that so much was learnt about the interior of the earth. The third, or mean wave, is the slowest and has traveled around the earth through the surface rocks.